Okay, something that you have encountered in physics more than likely, we have velocity, acceleration, and distance. And for the variables I will use in this introduction, okay, we'll have for velocity, okay, the variable v, acceleration, the letter a, and distance. Now, I'm just going to put this as the letter x, but just like in the case of following objects and stuff, like vertical motion, you can apply the variable y. Okay, and just to kick things off, okay, so again, now for what we have concerning acceleration, that's going to be the change in velocity with respect to change in time. So if I were to express this in differential equation terms, okay, so you have dv over dt is equal to a, and if I express the relation in terms of velocity, and just like the introductory homogeneous equations, okay, so if I separate the differentials, okay, so I have velocity is going to be the dependent variable t, in reference to time is going to be the independent variable. So just looking at separating, so I have dv is equal to a dt, and upon separating, okay, we can integrate, and the antiderivative of dv, we're going to have it v, and for a dt, antiderivative, okay, we'll say that we have at, and we'll say that we have, for the constant, we'll just designate this as c sub 1, okay, because I'm going to carry this over and put this in the context of distance. Okay, so now acceleration is the change in velocity with respect to change in time. Okay, now by definition, now velocity is going to be the change in distance with respect to change in time. So you can say that v is equal to dx over dt. But I would just have the derivative out at the front. Okay, and looking at once again, okay, now we have dx over dt is equal to v. And if I go ahead and put the parametric definition of what I have originally from the acceleration part, I'll go ahead and put at plus c sub 1 in place of v. So by substituting, so I will have dx over dt is equal to a times t plus c sub 1, and looking at, once again, separating the differentials. Okay, so this relation, okay, x, the distance, will be the dependent variable, and again, t is going to be the independent variable. Again, so I'm looking at separating, so I have dx is equal to at plus c sub 1 quantity, okay, dt, and looking at integrating over both sides. Okay, so the antiderivative of dx will go to x, and for at, I'm integrating over dt, and by the power property, okay, so I'm going to have the antiderivative of at is going to be 1/2 of a times the square root of t, and the antiderivative of c sub 1, okay, that will be c sub 1t, and we have followed by a second constant. And let's say that if I were to determine distance on the basis of given information, okay, so just to give you some examples here, say if I were to determine the distance in parametric terms, that is, in terms of t, and we will say given first of all, and we'll just start out with some constants. And we'll say in the first case, all right, we'll say that we have that a is equal to 30. And we'll say that we have v naught is equal to negative 25. And we'll say that we have at time 0 as well. We'll say that we have x naught is equal to 10. Okay, so looking at setting things up, again, by looking at the definition of acceleration, in case you have, again, you have dv over dt is equal to a. Well, guess what? A we have already assigned at 30. So you have dv over dt is equal to 30. Now, looking at separating the differentials, and integrating, okay, so you have the integral of dv, which is going to go to v, and antiderivative of 30 dt, that would be 30t. And so we're going to have that v is equal to 30t plus c sub 1. Now we have that v naught is equal to negative 25. And if I substitute accordingly, okay, so v we have at negative 25. And guess what? 30 times 0 goes to 0. So c sub 1 is automatically equal to negative 25. And so we have, with the information now added, it's going to turn out that for what we have for v, that is equal to 30t minus 25. And again, I'm looking at expressing the distance x in terms of t. All right, so once again, we have the change in distance with respect to the change in time is equal to v. And once again, I'm looking at, substituting 30t minus 25 for v. And separating the differentials. Okay, so I have dx is equal to the quantity of 30t minus 25 dt, integrating over both sides. So we have the x is equal to, and for the antiderivative of 30t, this becomes 15t squared minus 25t plus c sub 2. And looking at solving for the second constant, okay, we have information at hand with x naught equal to 10. Substituting accordingly. So x is at 10. Okay, so 15 times t squared, whenever we have t at 0, that becomes negligible. Negative 25 times 0 is negligible. And right away, we're going to have that c sub 2 is equal to 10. And so we have solving for x in terms of time t. It's going to turn out that we have that x is equal to 15t squared minus 25t plus 10.